Hello everyone, in this video we are going to take a look at how to build Celestia from the source code for the Windows platform. This is going to be a bit long video, but I will try to keep everything compact. First, if you are in a real hurry, basically the only thing you need to do are those two steps. Install all of those libraries using vcpkg and then generate your target build solution, in this case Visual Studio, by using CMake. The important thing here is you must pick which front end you want to use. There are three front ends: Qt5, Qt6, and SDL. And then you need to specify the CMake toolchain file, which is going to be your vcpkg CMake file. That is basically, in a nutshell, what you need to do. Now, there are two repositories you need to build, because just building the source code itself doesn't have all the contents. The other one you need to build is the Celestia Content repository, and that one is responsible for all the actual data files. Yeah, that's it. So basically, if you are in a real hurry, that is the two steps you need to do. Now, for those who are not in a hurry, and that's probably the reason why you are watching this, and I do recommend taking time listening to what I'm going to talk about, the process is much more complicated. First, let's take a look at the final result. I'm going to show you how exactly we get here, but this is essentially what we get, which is this folder. This is the eventual result. So this is the source code folder. The things we are going to generate is the build folder, and in our case, I am going to install all the vcpkg packages right inside. So we have the vcpkg installed folder. The eventual result is a folder that is about 4.2 gigabytes large, and then vcpkg installed contains all the installed dependencies, which is about 1.3 gigabytes. The build folder, after you actually do the build by using build the solution in Visual Studio, it's going to become 2.3 gigabyte. If I remember correctly, when you just generate the build folder, it should be much smaller, so something about 300 megabytes. So that's the general overlook. Now, in this video, we are actually not going to build the source itself, because this video is only going to show you how to generate the build file, because that one alone took me a while. And also there is compilation problems which I haven't been able to figure out, which I will make a video talk about it in the future if I ever figure it out. Also, we will not be talking about how to build the Celestia Content folder, because I also haven't figured out how to do that, but I'm going to show you how to generate the build files and what are the configurations you can use. Yes, so in general, the purpose of this video is to show you all the things you might encounter and to share a bit more on the fundamentals that might help you figure out the detailed steps. Now, in general, the biggest problem I encountered is just getting vcpkg and CMake build to work, and that took me alone like 3 hours just to get this to work. And then there are compilation errors, as I was mentioning. That one, I don't know, probably depending on your skill, that might take even maybe less or more time to deal with it. The actual compilation, if we don't worry about the compilation errors, it takes only about 15 minutes. So it's actually not a very huge repository. Now here's my verdict, just some comments I want to share. I think if you go through the whole process like 3 times, like what I have done, then it's going to make it feel smoother and fairly straightforward in general. And then the entire process, I think right now as it stands, is kind of hard for contributors to participate. It's I have decent experience in C++, but I still find it very hard to get it right. Definitely not something you just run a batch file and then everything set up for you. So I think this is going to be a bit challenging for this project. On the other hand, if you figure out all the stuff, and then especially the build system, then I think it should be fairly okay. Now, for now, because we are not able to actually compile the solution, so we're not able to debug through it, but I still feel this is very meaningful compared to just having the source code, because you can navigate the code much easily. For instance, if you want to find some functions, you can easily just using Visual Studio, and then you can find all the references, call hierarchy, or find all the references by using all the IDE features, right? So I think that is definitely a plus compared to just having the source, because now we have the project files, we can take a look at that, all those things in a much more easier fashion. So that is the verdict. Now let's actually talk about how do we do it, right? So before we can actually do anything, there are a few prerequisites that I think are necessary, which I'm not going to go through all the details, but I'm going to specifically focus on vcpkg. So you need to install it either globally, or in my case, I'm going to show you how to install it as a Visual Studio component. You don't need to see this one, that's for me. And then you need to install CMake, just to make sure it's available in the command line. And then after that, you need to make sure you install all the dependencies before you do the CMake generation, CMake build. Otherwise, it's going to encounter a bunch of problems. Basically, those are the dependencies we need to run. I'm going to show you exactly how to do that. And then the last point is, if you prefer not doing CMake from the command line, that is, you do not want to just type this one, then you can use something called a CMake Visual Studio Code extension. That is also the one that it's mentioned in the installation instruction from the source code, which I'm going to show you where it's mentioned. But make sure you pick the one by Microsoft, because there are quite a few of them. But I'm going to show you how to do that. So, and here are the key commands that we will be exploring. So the first thing we are going to take a look at is how do we deal with the those things, and where's the source code repository. The source code we have is from this address, Celestia project Celestia. That is the source code, and you can check it out by just open with GitHub desktop if you have it installed. I'm going to pick a location here, and I'm going to clone it. Now this one is going to take a while, so while it's downloading, I'm going to show you something else. This is the Celestia content that contains the data, as you can see, the actual standard, the models, those things. So supposedly, if you check this out and build everything, that will give you all the data files, because the previous repository only gives you the executable files. So that's 2 repositories you will need in order to build the thing yourself. While it's downloading, let me show you some interesting stuff that's available right here in the repository. Here, if you scroll down, you can see we have those markdown files, right? So the README file is just the text version of the README that comes with the solution, and the README.md file is the one that is shown here. The one that is of interest to us is this install.md file. So this one actually contains the not only installation instructions, but also how do you build it. For instance, if you search for Windows, you can find those instructions here. I'm going to go through that in a bit, because I need to make some comments on this one, but that's the general part. Also, if you are trying to build with MinGW, it also mentions here. Also, after you build everything, if you scroll down to all the way to the bottom, you can see you also need to install the content, and it also gives you some instruction on how to do that. Although this is not complete, that's why I will talk about more specifically how to do that. The other thing of interest, if you go to something called support, you can find there's a build64 command. That is a batch file, actually a Windows batch file, and it kind of also shows you what needs to be done. So here specifically, it's okay. This first one, I don't know what it's doing, but this one is showing you some of the packages it needs to install, and this particular syntax is installing into the global version of your vcpkg, the global cache of the vcpkg. And then it's showing you, you can do git pull, git update, and then make the place, set those variables, and then do those ones. Now, this one is not complete, and some of the stuff here I think is not necessary. For instance, this one, you don't need to explicitly specify that. I think so. Let me check my load. Yeah, I believe you do. Oh, actually, you do need to explicitly specify. Yeah, but this one is definitely not complete. You also have other stuff that you need to do. So just want to point out this is available here. Now let's go through the install.md file. Point out some of the interesting stuff. So if we scroll down, so it mentions how to do it on Debian and on Ubuntu, OpenSUS, GNU, Linux distributions, common build instructions. Now, common build instructions, it mentions this one, git some module update init, which is not necessary based on my experience, because it doesn't really use any some module. So the first comment on this one. And then if you scroll down, you can see for the Windows installation, you need to install all of those ones, right? in case you are not familiar with vcpkg, this is the name of the package. You type it in, like it's not a comment. You actually do type it like this, okay? And then for the version I have here, I'm not able to make use of gettext. I always run into a problem with the RIB-INTL. So I'm not able to RIB-INTL. I'm not able to do that. So what I'm going to do is I'm going to disable internationalization. And also, I'm not going to bother with the optional packages. Here it also mentions how do you install it for Visual Studio Code, and I'm going to show you how to do that as well. Okay. Another important thing here is, as a button, it shows you all the configuration parameters available for CMake. The important ones for us is you need to pick from one of those, because by default all of those are off. So if you want to generate any frontend at all, you need to pick either one of it. So that's this part. Next, let's look at the repository. Okay, so now it has finished. I am going to just open it in Visual Studio Code. First, let's look at the plugin extension you can use. If you search for CMake, you can see there are two most downloaded extensions. The first one is called CMake by TWXS, which I'm not sure what this one is for, but it doesn't seem to do much, so don't use this one. Make sure you use the one from Microsoft, which provide the command, like build command, like all of those commands in the if you do F1. So that's the one you want. The other thing is here, if we took a look at the prerequisite. Now let's take a look at how you can install vcpkg. There are two ways you can install that, as I mentioned. The first way is to install it globally. In general, if you want to install it globally, you are going to check out this repository explicitly. Okay, you are going to check out this repository and put it somewhere on your local that is safe, and that's where your installation is going to be. And the most important thing, the most important step is to essentially just run this one. If you just run this one, then it will install everything for you. So you don't need to do that much. So if we take a look at, so I would recommend you, if you want to see how to install it globally, take a look at this course by Troubleshoot. And as you can see, the two important commands is to just check out the repository, and then you can do a bootstrap. And that's pretty much all you need to do. Okay, so that's how you can do it globally. If you want to install it locally, open your Visual Studio and go to the Visual Studio installer. Here, go to Modify, and go to individual components and search for vcpkg, and that will show you this one. If you haven't installed this one, install this one, and that will give you the local version of vcpkg. In my case, the local version of vcpkg is going to be somewhere inside. Where did I put it? Let me just search for it here. So CMake, no, not CMake. So it's going to be vcpkg.exe. So I installed it here. So that is where the local version is going to be. To access this one, you are going to use Visual Studio developer command prompt for Visual Studio. That will have all the paths you need for vcpkg. You can see I have it installed right here. Right. So that is how you can install it locally. If you want to refresh the whole process, I recommend this video by Kyle, C++ dependencies in Visual Studio with vcpkg. That will show you how to install it locally. For our purpose, I'm just going to show you the most important commands you need to use. The first one is, if we go to our repository, if we open a command prompt, actually I'm not able to use this one because this one doesn't have a path. What I'm just going to do, I'm just going to copy the path and go to my command prompt here, cd go inside. The first one, the first useful command you want to use is to do vcpkg integration install. So that is the one you execute when you first installed vcpkg. That will make sure your Visual Studio is able to discover vcpkg. So after you install that, you can go ahead and create a new C++ project. So if we do any new project, and then you will be able to go to the project properties and you will be able to find this tab here. And it's by default going to use vcpkg. Okay, so that is the first command you want to use. The second command you want to use is, so the developer PowerShell here is the same as the developer command prompt. vcpkg, we can do add, okay, I don't quite remember actually. So it's going to be new application. Yeah, so you want to do vcpkg new application. That will create 2 files, and exactly 2 files and nothing more. And that is going to be, let me show you the project I have here, the temp vcpkg. That's the one I just created. It's going to create those 2 files exactly. And the first file, vcpkg.json, is empty for now because that is a file you use to add dependencies. So for instance, if we add a dependency like Lua, so you can do vcpkg add port, and you can do this guy, and that's going to add that to the JSON file. And here you can see that is a dependency that's being added, right? And then the second file that the new application command is creating is vcpkg-configuration. That one just supplying those 2 addresses to discover. I suppose this is where it's used to discover where all the packages are defined, and that is what they call in vcpkg jargon called a baseline. So that is our baseline right here. Okay, so that's the 3 commands you need to use. Basically, that's everything you need to do. The other one is vcpkg install. That will try to actually download and compile all the repositories into your current project folder based on your dependencies specification. So those are the few commands you need to learn. The next thing we are going to talk about is how do we initialize our Celestia project. So the steps is exactly like this. We clone it, which is going to be 500 megabytes. If we take a look at here, that's a clean one. So the Celestia folder is 500 megabytes. That's the fresh repository. And then you can do this one, but this one doesn't do anything. So you can do that. I think it doesn't do anything. And then what we want to do is to initialize a local manifest for vcpkg. Otherwise, whenever you install a package, is going to install to the global cache, and then if you have different versions, and then your different projects can have conflict. So what I'm going to do is to, inside the Celestia project folder, I'm just going to do the new application. That will create the 2 files, as I mentioned, those 2 files. Okay, so that is this step. And then after that, you just need to install all the dependencies that is required. Now, if we go to the install.md, you can see that it actually needs some kind of different dependencies. So if you go to Windows, you can see we need to install all of those and those things. I do not believe we need to explicitly do everything, but the command I have here pretty much should cover everything. So if you just do something like this, and then it's going to simply update this one. It's not going to actually install anything, just going to update it. Now this is the one I was mentioning. So gettext, you need to make sure you include this feature, because by default, if you just install gettext, it's just a library. But if you install the tools, that will also include a bunch of stuff that might be useful for development purpose. Although, as I was mentioning, we will not be building with internationalization. So this package, to be honest, you don't really need this one. So that's the packaging part. After this is done, what we are going to do, we are going to make sure we disable NLS, which will work around the problem with LB INTL. If you are able to figure out how to do that, probably you don't need to disable that, but for our purpose, we are going to do that. So before we actually generate a solution file, the last step we need to do is do vcpkg install. That will actually download and install everything. Since I already downloaded them once, I think downloading process should be fairly fast. But now here's the catch. If you just run this command, by default it's going to install to your local room folder, which is going to be where is it? If you go to common issues, it is going to be somewhere like this one. So it's going to be your user folder, AppData, local vcpkg, this kind of folder. So if you just do vcpkg install, it's going to create something called downloads and download everything there. But if you do this that way, especially if you are on a path that contains a space, it's going to cause issues later on. So instead, what I want to do is to redirect all the downloads to a different path. In that case, I am going to redirect all the things to C drive. I have a folder somewhere. I think it's in applications, and it's inside right here. So I'm going to download everything here. And in order to make sure the downloads goes there, you just need to set environment variable. So I'm going to set vcpkg downloads to this directory. So I'm going to just, before I install it, I'm just going to make sure I run this one. Now if you echo and take a look at the variable, you can see it's pointing to that one. Now when you do vcpkg install, it's going to use this folder instead. Now as I mentioned, I have already downloaded everything I need, so it should be fairly fast. And I'm just going to click run. So it's going to run. While it's doing it, there's one other issue I want to mention that you might encounter, which is related to the mirrors. So by default, whenever you are downloading those stuff, actually I can see it's kind of stuck here right now, right? It's not progressing. Okay, actually now it's progressing. But sometimes you're going to try to download something from this address, ftp.gnu.org. I think this address do exist, but for some reason, sometimes it can be very slow. Now, for now, I try to open it. It's not showing me anything, right? So when that happens, what you need to do, this will show you something like download failed, retrying after a while. What you can do instead is just to put this mirror, like in the address, and you can manually download it directly. So this address usually is faster. You see, you can manually download it and put it inside your download folder. That way you are downloading this using your browser or whatever way you download it, and then you just cancel this whole thing and then just do a vcpkg install. That will pick up the downloaded one directly. So another address that's causing problem is this particular address. Notice the address here has a pub inside. I don't know why it's directing to this path, but typically you do not want the path, it's just /gnu, right? So your program is likely going to stuck there as well. So you need to use this mirror instead. So in this case, you just download it yourself. Because of that, this vcpkg install process is not autopilot. You need to make sure keep an eye on it. Otherwise, it can take forever because of all those issues. After it successfully install everything, you should be able to see all of those cool stuff. It's just showing you those libraries is successfully installed, and when you are using CMake, you can use those commands to link and find those packages. So that is the thing you want to see. Basically, that part covers how you use vcpkg and how to do vcpkg initialization for the next step we're going to do, which is to use CMake. Now to use CMake, you have two steps. The fastest one is to simply just run this command. So what we can do is to just go inside. This one you don't need the developer command line. You just run it in a regular command line and specify your target format, the target folder, the source code folder, which is just the current folder, and then the architecture. And then in my case, I'm picking the Qt6, and then make sure you have the CMake toolchain file, which points to your which points to your vcpkg CMake. And then in my case, that is another issue you might run into, which is you will not be able to do a where is it? You will not be able to. Okay, this one I can actually fix it. It's not in here. This is a bit hard to read, by the way. So you just need to make sure you put this one here. So we disable internationalization. Or that is one way you can do that. The other way you can do that, which is going to do exact same thing, just you don't need to type everything yourself, is to make use of your command, which is a build command. Okay, but before we do the build command, you need to configure the build. And the way we configure the build is actually mentioned inside the install.md. So if you scroll down, you can see it's showing you how you can create this file. So what you do is to just go to create a folder called .vscode, and then create a thing called settings.json and put in this guy. Okay, and here you need to make sure point to your vcpkg CMake file, which in my case is this guy. I'm just going to put it here, and you need to pick which one you are building. In this case, I think we are using Q6. I think we should do true here, and then make sure in my case, because this one is not going to work, I'm just going to disable this one. So do this one and then false. So that's an alternative way you can run this same command. After you do this one, just find your command, run CMake build, and it's going to ask you to pick which is the compiler you want to use. So I'm just going to pick the AMD64. I don't know why there are so many versions. I think all of those refer to the same one, but I'm just going to pick this one, and then it's going to run. And it's going to, you can see it's actually executing the exact same command. It's also going to run vcpkg install for you, but since we already run it, and I actually prefer running it explicitly so we see what's going on, and then it's just going to generate all the build files. If you are lucky, then it's going to take a while, but you shouldn't see any error. Now, while it's building, let me just point out some other common issues you might encounter. So we talk about the mirror. I'm going to delete this one. And then we talked about the problem with this one. So when you are installing one of the libraries called eigen3, if you read carefully the output from vcpkg install, you can see this log. It's telling you that eigen3 uses a very long path and may fail on your system. So it recommends moving vcpkg to a shorter path. Right? So in my case, my vcpkg is already living a very long path inside Visual Studio. So if you install a vcpkg globally, you might not have this problem. But in my case, I also don't have this problem. And the reason is because I have already changed my operating system settings. So it permits very long paths. And this is a side effect. When I was installing Python, it will ask you whether you want to enable or want to disable path length limit, which I have already disabled it. So I'm okay with this. Another issue you might encounter is the this thing. So this one is actually interesting, and I think we should see an arrow because I haven't done this step. If we just let it run, so what is going to happen is there is an issue with another library called epoxy. I don't quite remember what this one is for. I think this one is for library. So this one is for handling OpenGL context. Yeah, similar to GLFW. So you may encounter this problem, and if we just read through the log, it's just going to say, it's trying to do something with this script, which by the way is the one that lives inside your folder right here. And then it's saying that it cannot find this library and this library path. Okay, but because we have actually already successfully installed it, the issue is just how the build system is set up for this particular Celestia project. The only thing we need to do is to make sure we explicitly add those paths. And the way we are doing it is to, now I'm going to show you how to do that. I think we should encounter an arrow when it hits there. But basically what we are going to do is we are going to execute this whole part. So we are going to execute this whole part, and I'm just going to remove the build folder, and then make a new one, and then set a variable, and this variable will point to the local folder that contains all the packages we have built. So in this case, it's going to be this folder. So here, right? So here, I'm just going to set the path to this guy. The path you see here is just referring to a previous one I was having. So I'm just going to set the root to this guy, and then I am going to CMake the to generate the build file. I don't believe we need to do this. If we are running inside, we can just do something like that, right? And then make sure we pick the Visual Studio architecture, and then the same thing here, and then Qt6. Or actually, when I was testing it, I wasn't using Qt6, and I was just using Windows. Probably that's the reason why it failed to build. But anyway, and then disable NLS, and they do this one. Let me just pick Qt6. I'm not sure why it will work, because I don't believe I installed Qt6. And then all of those stuff, and then just make sure you have all those three parameters set. And this, in this case, is set to the root, which is this guy. And inside it, we have our include, we have our bin, we have our lab. Just make sure you set this one, and that will successfully generate the build files. Okay, cool. So that is all the common issues you might encounter. Let's just wait for it and see what else we need to talk about. Okay, while it's still working on doing stuff, let me talk about how you build the content. So here we have the Celestia Content, right? This one is actually fairly straightforward. After you clone this guy, you don't need to do much to build it. But you do need to do something. So the thing you need to do, I think I mentioned in this page. So you need to clone it, cd into it, do the usual stuff. Now here's the thing. You need to make sure you have ImageMagick. ImageMagick, if you search here, you can see the ImageMagick parameter is referenced inside the CMake list. Alright, so you need to initialize those three parameters. Each one point to a specific. In my case, what you are seeing here is the one I already have. So it's not what you are going to see, but each one is going to point to the executable of ImageMagick. The script was apparently referring to an older version of ImageMagick, because as of ImageMagick 7, you no longer have separate ImageMagick, identity.exe, and convert.exe. The functionalities of ImageMagick.exe and convert.exe is now merged into the same one, so you can use the same path. The functionality of identify is no longer available, so this one will not work. But I was just doing this when I was testing it out. So you should probably download the older version of ImageMagick with legacy utilities, and then you can point your path to the corresponding utility file. So to show you an example, in this case, I'm just using the -d and the parameter name and the path to pass in the parameters as the executable path. In your case, you are going to use the older version, put it here, something like ImageMagick.exe, and then something like convert.exe, and something like identify.exe. And then also make sure you disable NLS. So that is how you can generate the solution file using CMake for Celestia Content. And you don't need to install any additional package. By just doing this one, you should be able to get your solution file. And then let me just show you what solution file look like. So here I can open the solution file. Although in this particular case, the solution is not containing a bunch of C# source files. So I don't know what exactly this one is doing. I think it's trying to use ImageMagick to convert some source data. But even though you can get a Visual Studio solution file, you cannot really do much useful with it. So that part I'm also pretty much stuck. So if I ever figure out, we probably will have a part 3 of this video. Okay, so this one look like it's stuck here trying to do this guy. Oh, okay, I think I know why. I think I know why exactly. That is because this one is, oh, my bad. That is because I haven't set the environment variable here. It's downloading into the old folder. Yeah. Let me just close this guy. Let me just close everything here. And let me just run the development command, and hopefully it will work. So I'm going to just skip the whole thing and do this one. You should encounter this issue, but I'm just going to skip this one here. And because I already set the download folder, this one should be quick, and the vcpkg install shouldn't be taking forever trying to download the stuff. Yes. There is a file system lock, so probably something is locking something. That's pretty bad. Is that because of this guy? No. Visual Studio. Okay, anyway, but you got the idea. Okay, we don't need to see it because I have shown you the final result already. But we have covered all the issues you might run into, and I will post all of those text in the video description so you can reference them later as well. Alright, thank you for watching.